So I'm going to let Julian speak on whatever subject he fancies. He did say he wanted to talk about cobalamin analogues, but I think he's going to be a bit more exciting than that as well. Over to you, Julian.
Thanks, Hugo. I've seen faces in this room I wasn't expecting to see, so it's a pleasure to see old friends and you.
Pleasure to see people, yes.
So I'm an orthopaedic surgeon at Addenbrooke's, where I've been for 23 years now. And my main roles are around hip and knee replacement. I have some management roles. I'm the musculoskeletal lead for Cambridge and Peterborough with Integrated Care System, which is about 1 million population. I have a role in health inequalities as the secondary care lead within Cambridge and Peterborough. And I've had some national roles in orthopaedics, president of the British Orthopaedic Directors Society. And then more recently, founder, member and chair of CLUB12 and a member of the Getting It Right First Time B12 programme, which we'll come to through the talk. I've got a whole lot of slides, and I know there's a variety of skill levels and knowledge levels in the room, so I'm going to talk very it's sort of basic science, but there are slides with more detail, and if I share the slides later, perhaps that's the time to read the depth of the slides, because there is too much information. So let's look at the bigger font, I think. So we're going to go through biological anthropology, because I think it focuses the mind about why vitamin B12 is so important. Then B12 deficiency, exacerbating factors in the 21st century, why there is underdiagnosis, because there is, why is there undertreatment, because there is. And then what I'm doing is going back years and getting papers out of the British Library and starting to bring it back to the modern world where we have modern techniques and we can start investigating things that were found back then, but we just didn't know how to test for them. And so we put it on hold. And then I'll tell you about CLUB12, which is the way we're doing all this. It's the focus, the center of the Venn diagram of everything that we're doing. So biological anthropology. I don't know what talks you've had over the years here, but this one fascinates me, that right at the beginning, 3.8 billion years ago, the first tetrapyrrole ring was formed, and that was probably in the primeval swamp. And it allowed, the first one of those had cobalt in the middle, and it's the precursor of cobalamin, but it's also the precursor of chlorophyll, and also the precursor of hemoglobin. But the chlorophyll and hemoglobin did not evolve in that pathway for 2 billion years. So we've had the B12 type compounds for longer, more than twice as long as we've had hemoglobin and chlorophyll. And hopefully that puts into perspective why it's important. So when people say it's just another vitamin, they're wrong. It is the most complex vitamin molecule, and it's fundamental to life because it allows us to transfer methyl groups, and that's fundamental to making RNA and DNA and basic cellular processes. So we need it. The problem is, in that pathway, there are 15 other cobalamin-centered molecules akin to B12, which we call the analogues, so the copies of B12. And we'll get to that, why that might be important, why the other 15, they're in nature, and 99% of what's in your colonic bowel bacteria is actually the wrong stuff, and only 1% is the right stuff. And then we might start to wonder what happens when the wrong stuff gets in the system. We've never described a disease where it does. So B12 deficiency, the pure form. When I was at medical school, I did a 3-month plus module at the Dunn Nutrition Laboratory. It was something I chose to do. You could have different modules at Cambridge to get your medical sciences degree. And we learned about megaloblastic madness. And I suppose that there is a problem that we don't talk about the madness side of megaloblastic madness much anymore. The Dunn Nutrition Lab closed with lack of funding. They took nutrition off the syllabus 10 years ago for medical school. And sadly, your doctors don't know that much about nutrition because they weren't taught it. And that's a problem if we think B12 deficiency is more of a problem than we're recognizing at the moment. I don't need to tell you all these things, but I like to share things that are published in reputable journals. So this is the British Medical Journal publication with Hunt, and just listing the various multi-system problems that B12 deficiency can bring. So mouth, I know many of you are familiar with these things: brain, neurological, bone marrow, reproduction, blood problems, cardiac problems. And NICE and the National Institute of Clinical Excellence set up to make sure that we spend our healthcare pound wisely, has sites talking about B12, and there's some useful stuff on there, and I think some of the GPs still need to read what's on there on how to treat B12 deficiency, etc. But it is there and it's published, and you can go and you can have a look at the recognised symptoms from NICE and some of the treatment protocols. In the 21st century, I think we're going to see more. We are seeing more B12 deficiency, and some of the reasons for that. Well, nitrous oxide, gateway drug. Those little silver canisters in the parks, the kids take them. It's not good. It destroys B12, and it destroys one of the enzymes that B12 works with, methionine synthase. So just remember that. Remember that it's growing in use. And so if our kids are using this, they're going to be more vulnerable to B12 deficiency. But not only that, when they get it, it doesn't measure on a blood test because the B12 that's damaged still measures on the blood test. So it's hard for people to pick up that the neurological problems that are being presented with nitrous oxide abuse are actually caused by B12 deficiency. But fortunately, there are neurologists now in the UK who are starting to publish papers on these things, especially a group at the London. They get so once a week, they get someone with major neurological problems, so akin to subacute combined degeneration of the cord due to nitrous oxide abuse. Here's your whippets. I don't know if you've seen those, but it's very sad when I do, and they're out there quite a lot. So then there's the healthcare professionals. Well, we use it, don't we? We put it in the labour ward. We use it in the emergency department. And the anaesthetists use it, not as much as they used to, because they're aware of the risks of using it. But strangely, the paediatric anaesthetists still like to use it for gas induction. So it's still used. It oxidizes the cobalt atom and the methionine. I won't go into that detail because that isn't the purpose of this slide. It's just to give you the general flavour of what's going on. In fact, we have, you remember Dr. Klein, I think, came and spoke to you a while ago. Andy Klein and I worked together. I think the reason you discovered Andy Klein was because I had spoken to him about B12 and he'd taken it to his practice and he'd realised that he was underdiagnosing B12 deficiency as well. He's an anaesthetist. He actually edits this journal, Anaesthesia, and we put an editorial together as well. So we're starting to get CLUB12 and CLUB12 people, which Andy Klein is one, so are these others, on the map as B12 experts. And that this is an article to try and take to the maternity units and the anaesthetists, and it's going to be presented at their national conference, Anaesthesia, with a debate with the neurologists later this year. I think it is in September. As well as that, we, as the group which I'll tell you about, have published on this. So another growing area where B12 deficiency is going to be more prominent is the move towards plant-based diets. So we know that vegans and vegetarians are more vulnerable, and it's a linear risk. The less meat and meat-based and animal-based products you have, the more likely you are to become B12 deficient. And sadly, it seems that not everyone who does that is aware of the need to take a B12 supplement. So we put this paper together with 20 world experts, tried to get it published in Lancet Planetary Health. We thought it was relevant. They didn't. But we did get it published in the European Journal of Nutrition. And you may have seen some of the fallout from that. It's being quoted in conversations about veganuary and plant-based diets now. And hopefully that awareness that if you are going to follow a plant-based diet. There's nothing wrong with that, but there is something wrong with not taking the supplement, because if you don't take the supplement, you'll get into trouble, and it'll be a bit like pernicious anemia. It will come on perniciously over a few years after you make that decision, and you probably won't relate it to that decision. We highlight the fact that it's very important to have your B12 levels right in the as a mother and the child, and it's a very dangerous time to be B12 deficient in those first 100 days of life. And there are other problems around it. But we know that plant-based diets, so this is interesting for me as an orthopedic surgeon, but if you're vegan, you're twice as likely to suffer a broken hip. And actually, that's the same risk as pernicious anemics in previous studies. Pernicious anemics, that when they were diagnosed, historically had already had twice as many hip fractures as the rest of the population. So there's some link around B12, plant-based diet, and broken bones, bone fault, for me to look into as time. So the key points from that: nitrous oxide abuse, widespread adoption of plant-based sustainable diets are exacerbating the issues around B12 deficiency. And then underdiagnosis. We have a number of things we can measure in the blood to look at B12 status. And this is a slide from Ralph Green's collaborative paper in 2017, published in Nature, about B12 deficiency. But these are the markers that are available to the clinician. Serum B12, holotranscobalamin, you might know as active B12, homocysteine, and methylmalonic acid. They're both markers of whether the cell is functional B12. If you don't have B12 in a cell, there are two enzymes that don't work, and they then can't process these two chemicals. So you get a buildup of homocysteine in the blood and methylmalonic acid in the blood. And you can combine all those into a formula to try and improve the accuracy of diagnosing B12 deficiency. Most general practitioners only have access to a serum B12. There are a few labs now that are offering holotranscobalamin to their population, and I think that happens in Norfolk, but I'm not aware of any general practitioner that can access these two tests. This test picks up serum B12, maybe 35% of people who've got a problem. This one, holotranscobalamin, picks up about 45% who've got a problem. Combining them all, you can get up to about a 70% diagnostic rate. But that leaves a third of people, even with these blood tests, that might benefit from B12 who aren't getting it. Part of the problem, this is some work by David Smith, who's the Emeritus Professor of Pharmacology at the University of Oxford. He did some work with Helga Refson, and they looked at where the methylmalonic acid changed according to your serum B12. Most labs will say you're replete on serum B12 above 200. So everything this way, the lab would say you're all right. But actually, the methylmalonic acid, one of these markers of B12 deficiency in the cell, doesn't get to normal and stop dropping until you're into the 500 or 600s. And the homocysteine kind of gives the same story. THC means total homocysteine. So you need a serum B12 of 500 picomoles per litre, way above the ranges of the laboratories, to actually normalize your homocysteine. And that suggests that your cell is happy when there's a serum B12 of 500. That seems to be a reference range used in Japan, I believe. So maybe they're onto something. I was told by our laboratory in Cambridge that if they'd used this, then half the samples going through the lab, and that's 500 a day, would be below that line. So they said, we can't do that. But they didn't have a solution of what to do instead. So at the moment, we just carry on reporting anyone who's below 200 and leave the rest. This is some work done in 2007 and published that explains those thresholds I was giving you. but essentially these are the numbers of your hollow TC, and the lower line is your serum B12. So this just to confuse things, this is a different set of units. So these units are picomoles per litre, and it's another problem around the labs because some report in nanograms per litre and some report in picomoles per litre. So the 125 is equivalent to 200, and that's why I say it's 35% sensitive. 150 would get you up to, which would be, you'd have to get, you can't get there, 100% sensitive, and you'd be way up here, and that's the problem with the labs. They've set these thresholds badly, though, because if you're only picking up 1/3 of the people that need treatment with your serum B12 test, we've got a real problem. And then to add to that, I've been working with the National Clinical Standards Group, so UK NEQAS are based in Birmingham, and most laboratories in the country will take a sample from NEQAS, a standard reference sample, every 3 months. So what they do is they get a litre of serum, so they pool it from various patients, and they mix it together, and they send a small amount to every laboratory in the country that subscribes, and that's 330 laboratories who do serum B12, and about 30 that do hollow transcobalamin. But here's an example that 327 of them actually came back from this one sample. So this should be the same. It's the same stuff. But these are the B12s that were coming back. And it's almost a normal distribution. So one lab had it down in the 70s, 80s, and another lab had it out the 260. And you can see what that means, that 51% were interpreting the sample as normal, and 49% of the laboratories said it's low. And that isn't even reproducible across the different machines. So there are 4 companies that make B12 tests, and even the same machine in a different laboratory comes up with a different result. So this knowledge has been sitting in NEQAS for some time, and they don't know what to do with it, but they know it's a problem. Now, if you add to that what was published, this is going back a long, long way to tell you the history of some of the previous blood tests for B12. We've been through a blood test where you grow algae on human serum, you grow bacteria on human serum, and then some more sophisticated tests with radio. I might skip these slides, but it's safe to say that back in 1978, a chap called Bob Allen, in there somewhere at the end of that list, published in the New England Journal of Medicine saying, we've got a blood test at the moment that's measuring B12 analogues. And that actually got everyone re-looking at it, and they were missing diagnoses back in 1978 because the blood test wasn't accurate for B12. I'm going to flick past these and show you what was then found when they sophisticated that test and got it more accurate. So until about 30 years ago, we had a more accurate test, and then we brought in something called a competitive binding luminescent assay. And that came in because it sat with the automated system that sit in the laboratories in the world. So you've got a sort of robotic arm taking a sample, putting it in the machine, and it measures your full blood count, your urea and electrolytes, all in one go. And so the manufacturers moved over to this and supplied the cassettes, and for the last 30 years we've been using the competitive binding luminescent assay. And the problem is that isn't any good either, and I've just shown you how bad that is. But Ralph Carnell exposed this in 2012, so we're 11 years since this revelation that the test is no good. And what he showed is he dug out old radioisotope dilution assay samples that he had in the freezer. And these were the levels that he was getting from that test. So 0, 10, 13, these were all B12 deficient patients. Then he put it in the modern analyzers. And I'm sorry to say at Addenbrooke's, where I work, we have number 1, which is the Siemens assay, but there's a Roche assay and an Abbott assay and a Beckman-Coulter assay, and he used 3 of these to see what happened. And you can see some very high results, especially this sample. 88, that patient would have been treated historically, and they would not in the modern world, on 3 different platforms. So he came out and into the New England Journal of Medicine, and that's published. But did anyone do anything about it? No, there was a bit of talk. Our clinical chemists, the Association for Clinical Chemistry in the UK, actually published a patient safety warning that false normal B12 results and risk of neurological damage. So they used that paper to publish this. But did that get listened to? Well, no, because that's the clinical chemists, and their ability to communicate with the doctors doesn't seem to be there, even what we think is good modern governance. So that's a frustration. And this was the statement that they put out on their website, but it's much the same as what the NEQAS statement is, much the same. But this is from our body that supplies reference samples to the labs, came out and said there are problems with this blood test. Treat the patient, don't delay, and do the methylmalonic acid and holotranscobalamin assays if you can. But the GPs can't. Under treatment. So that the conclusion there is we've got what the National Lead for Clinical Chemistry calls a crap assay. And now let's talk about treatment. Well, NICE, as I told you earlier, does have a good treatment algorithm for neurological B12 deficiency. Hydroxycobalamin 1 milligram intramuscularly alternate days until there's no further improvement. Now, I know there are people in the room that are thinking that's not how my GP would treat it. And that's the problem. So that message, despite being published on a national site, respected NHS body, it's not actually followed. And then you're into this dreadful system where our clinical commissioning groups, now integrated care systems. So over the last few years, we've been moving to incorporate social care and health in one body and work with the charities. And those units are bigger than the CCGs of old. And there are about 46 of those in England, in NHS England. So I work with our integrated care system in Cambridge and Peterborough, and I've said that's 1 million population. And each of these CCGs, integrated care systems, have looked at the literature themselves, often with a public health registrar, without much knowledge of B12. So they rely on the literature and they come up with a pathway. And then the pathway is published, and that's what the GPs are measured on. Are you following our pathway for the management of B12 deficiency? So I'm embarrassed to show you the Cambridge and Peterborough guideline. But this one, anemia or strong suspicion of B12 deficiency, visual disturbance, memory loss, psychiatric abnormalities, loss of peripheral nerve function that can result in impaired sensation. Check the B12. If it's over 150, offer dietary advice and recheck in 3 months. Now, we all know what that will do to those patients. They'll just get worse and worse and maybe irretrievable neurological damage. So I'm in conversation and within Cambridge and Peterborough, I am allowed to rewrite this. I'll tell you why I haven't done it yet, because I will tell you now. I don't want to do it in one ICS. I want a national pathway that we all agree on, as best we can, to save this postcode lottery, this health inequality according to where you live, about how you're managed. Now, there are enlightened places within the UK, and St Thomas's Hospital, if you get ill and you've got a B12 problem, you want to be an inpatient in St Thomas's Hospital, because there the clinical chemist, Dominic Harrington, ditched serum B12 a decade ago, and he doesn't use it in his diagnostic algorithm. He does a holotranscobalamin on any inpatient samples. He hasn't got the money to do it for every GP sample that comes into his laboratory. So he worked with the gastroenterologists managing Crohn's disease, and And this is what he found. When you did a serum B12, people with Crohn's disease, you found 5% were deficient. If you used the whole OTC, you got 15%. But if you added the methylmalonic acid, you found that 32% of your Crohn's and inflammatory bowel disease patients needed B12. From 5% undertreated to 32%. They've published it. It's there in the literature. Ward et al. Do my gastroenterologists in Cambridge know that? No, they don't. And then you'll be all too familiar with this, but these are really important papers that are getting into the literature now. The reality is we won't get anywhere in medicine and with the bodies if we don't have evidence. And this evidence, which we call real world data now, patient evidence, what's actually happening to the patients, is really important. And there's a nice B12 deficiency program going on at the moment. And luckily, the new medical director of NICE that's doing that program is admitting real world evidence into the B12 deficiency program. So this stuff would have been discounted 2 years ago. It's now being counted in the production of those guidelines. But 4 out of 10 patients with B12 deficiency self-medicate at home. That, you know this, but that's the tragedy, and we need to address that. But it's in the literature now. So you can go to the learned bodies and they have to listen. So the key point here is an over-reliance on serum B12 competitive binding luminescent assay with a 35% sensitivity for vitamin B12 deficiency has led to a National Health Service that underdiagnoses and undertreats B12 deficiency, a known comorbidity in a broad spectrum of health conditions. So that's sort of part one. Part two is a conversation about B12 analogues. And I think I'm going to go quite fast through this, but I just want you to know that they exist and they have been implicated in disease, and no one yet has proven that they don't cause disease. And they certainly could confound tests. They certainly confounded previous blood tests for B12 deficiency. So we put on a little seminar at Addenbrooke's with these fantastic experts, Martin Warren, who I co-founded CLUB12 with. He's a biochemist who actually defined the last part of the pathway that bacteria synthesize B12, and Jean-Louis Guéon, who heads up the equivalent of a medical research council unit in Nancy, who wrote a book on B12 analogues as a young researcher, put it on the bookshelf and didn't look back until I told him he ought to get it off the shelf again and start looking again, and he's listened. So he did those talks for us. We'll go back to Robert Holt Allen. It's not me that thinks analogues might be relevant. He found that they produced false blood tests, but he also came out, and I'm going to flick through these. These are the blood test slides. I think this is all too much for you, but they're in the slides if people want to read a little bit more. One of my B12 heroes is a chap called Victor Herbert, who was a hematologist, and some people say he was in the equivalent of the special forces in the US. So he was an overachiever. But he started to have some ideas that analogues might be relevant to human disease. Here in 1984, he's writing that free analogues might attach the B12 intrinsic factor complex accelerating the development of B12 deficiency analogues from bacteria. Some analogues, he said, might be absorbed and block metabolism in the human tissues. And we've never looked at that to see if that's true or false. But Ralph Carmel, who we talked about earlier, that wrote the paper comparing old assays with new, did find more analogues in the blood of people with neurological symptoms in their pernicious anemia. So there was an inverse relationship of analogue level with the severity of anemia. Suggested disproportionate accumulation of analogues to explain some patients with cobalamin deficiency display neurological abnormalities while others do not. And he parked it in 1988. This is how old the literature is that talks about these copies, these antivitamins, these faux B12s. There's a sniff around analogues with multiple sclerosis, published in 1992. Indeed, one of my colleagues here is a rehab medicine consultant who wrote this paper, Stephen Kirker. I asked him why he didn't go on to look into why various parts of multiple sclerosis and disturbed vitamin B12 metabolism, why he didn't move on and follow that through in multiple sclerosis. And he said, we did not have the tools to prove it. I knew I'd have a dead-end career if I tried to, so I went into rehab medicine. So parked the links between B12 and multiple sclerosis. And these are some more of those links. Interesting, there is, and I talked about this when I met Hugo and other colleagues. There were patented and FDA approved slow release B12s in the 60s when B12 evolved. Everyone thought, well, why are we injecting frequently? Why don't we have a slow release B12? And they created these zinc tartrate compounds that when you put them IM, they slowly just let the B12 out over 2 or 3 months. And if you give that to someone with MS, then more of that B12 gets into the cells. So slow release B12, never been a therapeutic trial to see if it helps people with MS. Crohn's disease, again, people B12 deficient, analogues competing with vitamin B12 in Crohn's disease for absorption. Alzheimer's. This is interesting, I guess, because those carrier proteins that deliver B12 to the cell and the protein that accepts B12 to the cell, so you've got a carrier protein which goes to a receptor, and the carrier protein with B12 hits the receptor and gets brought into the cell. What no one's explained is why, if you have a genetic variation of your carrier protein, it can predict your risk of Alzheimer's. Also, we haven't explained why, if you have a variation of the receptor for B12, why that would predict your risk of Alzheimer's. It could be just that B12 is so integrated in the cause of Alzheimer's, though the modern research is not into B12 and Alzheimer's. Indeed, the Alzheimer's Society has 30 million a year research fund, and they've put B12 as a low priority. We're not going to fund B12 research in Alzheimer's. But these findings are there, they're in the literature, and no one's explained why your carrier protein and your receptor for B12 metabolism might define your Alzheimer's risk. So another area to open up again in research. I wanted to know whether some of these analogues actually affected our current assay, much as Bob Allen had shown back in the 80s. So I went up to Birmingham and took some factor 3M. 3M is one of the 15 natural analogues of B12, and it's the most accurate copy. So it's the best counterfeit around, and it would pass as B12 in some systems. The assay is really good, but it did count 15% of the 3M that we put in the sample that went to 330 labs. So if you have a lot of analog in your blood, it will gently elevate your serum B12 to the test. And again, it might just put you over the line for your blood test to say you're not B12 deficient. And it's not good B12 that's doing that. We haven't published this yet. So all that was a real driver. But the main driver to get me into this in the first place is a family tragedy which will never go away. It lives with us and our family. And it triggers why I'm involved, but it isn't the main reason I'm involved now. What I've uncovered are things that are not related to what happened to us. But Georgina was 21. She was a vegan. She did that for 3.5 years. And we did have conversations about whether, as a plant-based diet, you should take B12. She kind of didn't believe it. I did, but I didn't realize how fast and how toxic B12 deficiency might be in her case. She suddenly thought I might be a bit anxious, perhaps it's B12, 3 weeks before she became psychotic and took her life. And she took 1 milligram of B12 a day for those 3 weeks. And we had no idea she had a delusion. Subsequently, we have found that her methylmalonic acid was up in clotted blood that went down to the toxicology unit, and she wasn't on any other substance that might have made her delusional. A professor, the Cambridge professor of early delusional states, acute schizophrenia, hadn't been testing for B12 deficiency in his patients and wasn't considering it, has looked at the evidence and says, I do now, you're onto something, keep me posted, I'll do anything I can do to help you understand the links between plant-based diets, B12 deficiency and psychiatric disease. And we have got more samples to test to work out what actually happened with Georgina's cells, and Jean-Louis in Nancy is going to help me with that. But that was the start of it. I went down to Canterbury to meet Martin Warren, who I was told could test samples from the healthcare stores to see if they really were B12, to see if what Georgina was taking was B12, and it was. But Martin's daughter was taking a supplement that was half B12 and half analog. And when you start looking at what's available in the stores, there's a whole lottery, a Russian roulette of what you're buying. Some of it's pseudo B12, sometimes some of it's breakdown products of B12. It's regulated by the Food Standards Authority, not the health regulatory body, the MHRA. So we set it up because Martin said, we need a little group in England to bring B12 researchers and doctors together, although at that time there was only one doctor, GP, interested in B12, Wilhelmina Retzma. She was down there as well. So the three of us set up CLUB12. Martin Hooper helped me design these objectives, who set up the Pernicious Anaemia Society. Stimulate discussion of the uncertainty surrounding B12, promote and encourage research into all aspects of B12 metabolism, encourage multidisciplinary conversations around B12, and disseminate those research findings to clinicians and the wider public. And they stand 3.5 years on. Those are our objectives. I don't feel any need to change them. We've got 170 members. We've got neurologists, hematologists, psychiatrists, gastroenterologists, endocrinologists, obstetrics and gynecology, trauma and orthopedics, and then primary care, psychologists, clinical chemists, biochemists, genetics, charity and lay members, and a few of you in the room. I didn't know you came to this meeting as well. And we are trying to talk together, and those groups are represented within CLUB12 now, and we have a separate conversation out with CLUB12 because sometimes that it's easier to do that and want to make sure that we're all singing from the same hymn sheet. And if we've got aligned goals in our charities, then let's work together and create that collaboration. What have we shown in some of these meetings? We've shown that low B12 and high folate diet in rodent models delivers autistic rodents, and that's brain slices. So if we ask our mothers in the UK to take folate, we then know that they might take a little bit more, and then they're on a vegan vegetarian diet with high folate and low B12. What does that mean? That research needs to be looked at hugely. Does that explain in part the growth in autism or autistic spectrum disorder? We don't know, but we know it does in rodents. And I should put mice. I re-looked at the paper. It's not rats, it's mice, and I apologize for that. But there is a $2.6 million grant being given to further that research in California. And these are all people that are part of CLUB12. We had some people who are researching MS come to CLUB12 because they realized that that was the body with the expertise, and they found various things around multiple sclerosis, but a human astrocyte has down-regulated B12 receptors. So if in multiple sclerosis your brain and neurological cells don't have as many receptors, then that means they're not getting as much B12. Is that part of the disease? We don't know. And then Parkinson's disease. One of the presentations of Parkinson's one of the presentations of B12 deficiency is Parkinsonian-like features. And this enzyme, which isn't in the books as a B12 dependent enzyme, is actually modulated by B12, and it's a bit faster if it has B12 attached. So leucine-rich repeat kinase 2 might be the link between B12 and Parkinson's. So what have we done? we did influence very early on that dreadful COVID guidance that came from the British Society of Haematologists. I managed to get in touch with Mount Garg, who chaired the guidelines committee, said that the patient groups are not happy with these guidelines. Can you meet with them? And we did. Martin Hooper came along and Dominic Harrington, and they rewrote the guidelines to allow pernicious anemics to have iron injections, which was not the early COVID advice. It was everyone could go onto all. So we changed that. So I realized that we had an ability to influence. Some of you know Karosh is taking a breakaway group to push pernicious anemia further, and the Pernicious Anaemia Society have kindly supported a PhD student who's doing great things for us at the moment with our NICE response, Alfie. We are involved with that. We've got members who are actually on the NICE committee. They've declared CLUB12 as an interest, but we're then confident that the right people who understand it are on the NICE committee doing the best they can. A long time ago, my professor here said, why aren't the Pernicious Anaemia Society doing a James Lind Alliance priority setting partnership? But I spoke to Martin Hooper, and they have now done that. They've invested a lot of money in that, 30,000 I think it was, but this is a process where you work with National Institute for Health Research, their charitable arm called the James Lind Alliance, to develop your priorities, and then NIHR are more likely to fund projects that deliver the top 10 priorities for research within the charitable area, which is pernicious anemia and B12 deficiency. So NIHR have got a pot of money they're ready to spend on research into B12 now. We've already put in several grant applications for research collaborations. And there's another one just got in. I've told you about the European Journal Plant-Based Diets paper. GIRFT B12. As an orthopedic surgeon, I've been through the metal-on-metal hip replacement problem, where 500,000 patients worldwide were given metal-on-metal hip replacements on the basis we thought it was better, because the laboratory studies suggested it would be. But actually, our National Joint Registry showed within 5 years that the redo rate for metal-on-metal hips was higher than we'd expected. It was unwarranted variation. It was an outlier. The president of our orthopedic association at the time started a program to deal with that and to make sure it didn't happen again. We now use all the databases to follow what we do. NHS England Clinical Improvement liked the methodology. Professor Tim Briggs is now the national lead for clinical improvement, and he has 30 getting it right first time ambassadors in every speciality. So we have a neurology GIRF lead, we have a psychiatry GIRF lead, we have 3 clinical chemistry GIRF leads, we have a hematologist. So I went to him maybe 3 years ago because I knew him and said, I think there's a problem around B12. What can you do about it in GIRF? And he said, when you're ready, bring the evidence. I'll put you in front of my GIRF leads. And if they see unwarranted variation in how B12 is diagnosed and managed, we'll set up a project. Well, that project's going. We've been using NEQUAS to survey all the labs in the country. We're using the NEQUAS data. We will come up with guidance in tandem with NICE because the NHS organisations are talking, but we'll do something different. But I'm on that committee, and we will, with the GIRF programme, produce a B12 management pathway, and we will come to charities, etc., to make sure that pathway is appropriate. I've been to NHS Patient Safety and spoke to the safety lead. He tells me he can't put that safety advisory out nationally. It needs to be done by each society. The gastroenterologists need to look after gastroenterologists. The haematologists need to look after haematologists. So we need to pick them off one by one. We can't do a national patient safety thing, but we can do that, and we can do that better with our GIRF leads. So I'll save that, but we will do a patient safety program as well. We were asked, one of our CLUB12 members, to prepare the latest BMJ article in a series. This one will be therapeutics, how do you treat B12 deficiency? That's in its 3rd iteration. It's been a year of toing and froing. We're hoping soon the BMJ will be happy with it and it'll get published, and it'll say more things than you're used to about B12 management. It'll be closer to what you think's right. We've had our first symposium, which the Pernicious Anaemia Society kindly helped fund. That was in Cambridge last year. I did present those early slides to a patient safety conference, which included past presidents of Royal College of GPs who were very interested. So they're just not aware. I have had a conversation with Royal College of GPs. We hope, and there's one of the other charities that may be represented in this room that are working with them as well. Hopefully we can improve the syllabus to do better education for our GPs. And we've got a couple of up and coming meetings. Through all this, we were asked to host the European meeting for one carb and metabolism, B vitamins and homocysteine. So it's the 14th meeting. It's happening in Cambridge in September. And it's already going to be a bigger meeting than CLUB12, and it brings in other B vitamins. It's a larger scale meeting, and it's taken a lot of my bandwidth. And in tandem with that, we're inviting people from Cambridge to Oxford to discuss another area of vitamins, but also part of the B12 pathway, and that's sulfur amino acids. So there's an Oxbridge thing there, we're getting quite a lot of transatlantic American interest coming over for these two meetings, so we can meet face to face and pursue our goals. There are ways of measuring B12 that I alluded to, modern science. Well, microbiology can be improved. The algal assay can measure pseudo B12 and B12. We're doing that in plant biology in Cambridge with Alison Smith. Mass spectrometry, Martin Warren has bought a new machine for 400,000, and he can now get down to serum levels of B12 on a mass spectrometer, which will also identify analogues as well. So you just get a spike for each one, which is really exciting. There are pharma that might be interested in reintroducing a depot B12, though if you want to go to Egypt, you can buy it £2 for 2 syringes with 2 green needles, which historically lasted pernicious anemics 3 months without wanting another injection. It was used in Denmark for 20 years before they chucked out cyanocobalamin. We've brought together various people that are developing a functional outcome score. If you're going to measure a treatment that works in the B12 space, you need a score that measures symptoms, and it needs to be validated, and that's happening with a link between the B12 Institute and a couple of universities in the UK. So hopefully we'll have a validated score for research soon. But that's another foundation block that we need to move this science forward. And I suppose personalised medicine coming and Karosh and what he's doing in the B12 breakout group would probably be that. One day, I think we need to relook at Alzheimer's and MS, inflammatory bowel, Parkinson's, schizophrenia. There are elements of the B12 pathway that are linked with schizophrenia, autism, chronic fatigue, long COVID, fibromyalgia. And I've got an orthopedic space here. Frailty, fractures, falls. If you can't feel your feet and you're confused with B12 deficiency, you'll get a fractured neck or femur. And just to finish here, this is 1998, William Beck, and I think this sort of just puts it all together. The stalwart little band of investigators of vitamin B12, now more rashly termed cobalamin. There is comfort in knowing that the stream of important scientific problems will never end. If the past is a guide to the future, there will be difficult problems inciting tumult and controversy, and in the end, they will yield broad biologic insights and many surprises. And I absolutely believe that. 4 Nobel Prizes, there's more to go in the B12 space. That's CLUB12 website. I can go back to that. It's here, and those are my email addresses if you wanted to contact me. That's CLUB12, and those are the sorts of things we're doing and what I'm doing.